Hi everyone, here's another example of what we can do with dot products and vectors. So if I know I've got two vectors A and vectors B, for what value of x will that vector be perpendicular to that vector? Now, let's have a look at what we can do. If we're talking about being perpendicular, what do we need to use? The dot product. So we're talking about getting the dot product of, so I've got A dot B. Now, I'm not looking at the magnitude of A and the magnitude of B and using the angles in between. All I'm looking at is this vector is called 3 and x, and this vector is 4 and 3. And I want that to be 0. If that turns out to be 0, then I know what value of x that is. Now, some of you will see it by common sense. Look at the top, we go 3 4s are 12. And at the bottom I go 3x, so we're multiplying the I values, we're multiplying the j values. We don't have to look at the I and the j values because if they're perpendicular to each other, when you multiply perpendicular vectors you get 0 anyway. So we're only looking about the I times the I and the j times the j. And that has to be 0. And it's pretty obvious now that 3x is minus 12 and I get x is minus 4. So if we go back to my two vectors now, the vector A becomes 3i minus 4j, and the vector B becomes 4i. And I did the numbers on purpose to make them look, so it's pretty obvious that this is 3 and 4 and this is 4 and 3. So at this point I could draw up a diagram and I can go, oh, I don't even need axes. I can just go 3 minus 4. So I go from here, I go 1 2 3 1 2 3 4. So there's vector A. And the other vector, if I start at the same point, go 1 2 3 4, that's your 4i plus 3j, and you can see that there's vector B. Now you can see that the two of them are perpendicular. By the way, the gradient of A, so if we talked about the m of A, what have I got? I've got got to talk about the rise over the run. So let's have a look at that. It's minus 4 over 3. So the gradient of that one's minus 4 over 3. So we're talking about the gradient goes to the length. There's a negative gradient. So there's its rise and there's its run. I could have drawn it over that way instead. What's the gradient of B? It's a rise again over the run. So if I drew that in to make it clearer, you can see it's 3 over 4. And how do you show that two things are perpendicular? When you multiply their gradients, you get negative 1. So let's have a look at it. So we've got minus 4 on 3 by 3 on 4, and that equals minus 1, which says they're perpendicular. So what happens? What are we doing when we're looking at these two vectors here? Well, they've got to be the reverse of each other. If this is 3 and 4, whether it's a negative or a positive, that has to be 4 and 3. But one of them has to turn into the opposite sign. So if the 3 became a 4 and the 4 became a 3, let's go over here. The 3 became a 4, the 4 became a 3. But one of the signs has to change, so that one turned into a positive. By the way, if they both turned in to a different sign, I'd just be going the opposite direction. So if I did it for a moment, I went over to here and I said, let's make that the opposite sign and make it a minus. So I'd go minus 4, and I'd go plus 3, and I end up with, what do I end up with? Oh, that's a mess.